Hello engineers, welcome back. In this video, we're going to practice another question for the greedy method. I hope you're ready. Let's get started. In this video, we're going to look at this question, maximum number of coins you can get. So let's try to understand the question and then we'll see a solution. Right? So there are three n piles of coins of varying size. You and your friends will take piles of coins as follows. In each step, you will choose any three piles of coins, not necessarily consecutive. So this is the first thing. You will choose any three piles of coins of your choice among the three piles that we choose. Alice will pick the pile with the maximum number of coins. You will pick the next pile with the maximum number of coins. Bob will pick the last pile. Repeat until there are no more piles of coins. Given an array of integer piles where piles of I is the number of coins in the ith pile, return the maximum number of coins that you can have. Okay, so let's try to understand this with an example. So let's say these are my piles 241, 278. 2, 4, 1, 2, 7, 8. Among these, the first step is I will choose any three piles. So I will choose a triplet, any three. Let's say I have chosen 2, 4, 1, first three. Among these, Alice, there are three players, Alice, you, and who's the third one? Bob. So among these three, Alice will get the highest one. See, Alice will pick the pile with the maximum number of coins. So Alice will get 4. Whatever is remaining among them, you will get the next highest. So you will get 2. Right? You will pick the next pile with the maximum number of coins. Whatever is remaining will be going to Bob. So Bob has no choice. Bob will get value 1. Okay. So where is the choice? The choice is in picking the piles, right? These are my piles. I will choose these piles. Whatever I choose, they will be distributed among the three players in this fashion, right? Alice will get the highest. The next highest will go to you. Bob will get whatever is remaining, right? So what is the uh, criteria here? This is the input, and the constraint is Alice will pick the highest. Alice first highest, Alice will take it. You will get next highest. These are my constraint. Bob will get the remaining. These are my constraints or conditions. Now, what is the question asking us to do? It is asking us to do maximum number of coins that you can have. I am interested in use maximum coin. This is where optimization comes in. You should get maximum coins. Max coin. So these are my conditions. So how will we come up with a greedy criteria so that you will get maximum coins, right? So let's see. Now, the straightforward way you might think is we'll just sort this array and whatever is the highest, we'll start picking from there. So something like this. I'm sorting this like this: 8, 7, 4, 2, 2, 1. And I will pick the top 3 and give it to Alice, you and Bob. So let's say these are my players, Alice, you and Bob. And let's say you have picked 8, 7, 4. Now Alice will get 8, you will get 7, Bob will get 4. And you will pick the next pile, which is 2, 2, 1. Now Alice will get 2, you will get 2, Bob will get 1. So that way, what is the total of you? You will get 9, right? And this example also does the same. The maximum number of coins you can have are 7 plus 2 equal to 9, and that is the output. So this works in some cases. But why should I give 4 coins to Bob? I have a choice, right? I have a choice to pick anything. Why will I give 4 coins to Bob when I can give him just 1 coin or 2 coins? If I picked it like this, 8, 7, and 1. Now Alice will get, so let's say this is my new picking. Alice will get 7, you will get, Alice will get 8, you will get 7, and Bob will get just 1 coin. If I do this in my next pick, what is my next pick? What are remaining? 4, 2, and 2. These are my remaining ones, right? So Alice will get 4, we'll get 2, and Bob will get 2. So in this case, I got 9 for sure, but Bob got less, right? Bob got only 3, and Alice got 12. So if I choose differently, I am able to alter the profits or maximum coins of the other players. Right? But what am I interested in? I am interested in just maximizing my thing, right? So let's look at another example to understand this better. So this pile, let's take this pile. So this is just 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take this. And if I sort it, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In our previous technique, what did we do? We just picked the top 3 and distributed among the players, right? So this is Alice, you, and Bob. So if I pick the top 3, 7, 8, 9, Alice will get 7, you will get 8, Bob will get 7, Alice will get 9, sorry. Alice will get 9, 9 get 7. And then the next 3, Alice will get 6, you will get 5, Bob will get 4. And then the next 3, Alice will get 3, you will get 2, Bob will get 1. So what are the totals here? The total is 9 plus 6, 15, 15 plus 3, 18, 8 plus 5, 13, 13 plus 2, 15, 7 plus 4, 11, 11 plus 1, 12. So if we do it this way, the profit or maximum coins I'm getting is 15. But can I do better? My question is, why should I give Bob so many coins? I can reduce it, right? Let's see a different approach. Instead of giving Bob all the coins in this way, we can do it differently. I have a choice to pick any pile, right? So that's what the question says. In each step, you will choose any 3 piles, not necessarily consecutive. I don't have to choose them in a consecutive order. Like, so I will pick it in a greedy way so that I will get maximum profit. So how will I get maximum profit? I cannot take the highest available value, right? Because I need to give Alice something. Alice will take the highest. Whatever is remaining in that, I will take the next highest, right? So that's where I'll be. So I will give Alice the highest. So let's say Alice will start here. I will give this to Alice. No problem. You take the highest. Whatever is the next highest, I will take. This is Bob. Sorry, this is you. So whatever is there at Alice minus 1 will be the next highest because this is a sorted list, right? So Alice will take 9, I will take 8, but I don't want to pick 7. I don't want to give Bob 4 coins. Bob will just take anything that is left. So I will pick the lowest value. I can put Bob here. So how will my pile look like? My pile will look like this: 1, 8, and 9. Among these, let's say this is Alice, you, and Bob. Alice will get 9 for sure. Whatever is remaining, among those, I will get the next highest. So I will get 8. And Bob will take whatever is remaining. So Bob will just get 1. Now I will repeat this process. Now I can choose. So this is done, right? And 1 is done. So now among the remaining ones, Alice has to get the highest. So I will give Alice 7. Let's say I've given Alice 7. What is the next highest after that? 6. So I will take 6. This is my maximum possible value. But for Bob, I will not give him 5. I will give him the next lowest value. So Bob can take this one. Bob, you take the next lowest value. So Alice will get 7, you will get 6, and Bob will get 2. And what is remaining? Remaining ones are 5, 4, and 3, right? 5, 4, and 3. Among these, I can directly distribute 5, 4. Same process. So now Alice will get 5, you will get 4, Bob will get 3. Now let's do the total. 9 plus 7, 16, 16 plus 5, 21. 8 plus 6, 14. 14 plus 4, 18. 1 plus 2 plus 3, 6. So I have reduced the Bob's value to 6, but I have increased my own share to 18. And in the process, I have increased Alice's share as well because we are picking the highest values, right? So if I follow this way, I'm able to increase my maximum number of coins possible, right? And that is what the output also says. You have to return 18 and not 15. Okay, so that will be my greedy criteria. My criteria is like this now. So what is my greedy criteria? First, obviously, sort the piles. Then give Alice the highest. You take the remaining, you take the next highest. Bob will take the lowest. Bob takes lowest. That's it. If we do this, we are greedy, we get the maximum possible coins. So that's it. That will be our solution. So let's try to code it. So first thing, we need to sort it. So let's sort it. Sort piles dot begin piles dot end. So this will give us sorted vector in ascending order. Now what do we need? So just for our understanding, let's create 3 vectors for these 3 players. Let's say this is Alice, vector int Alice, and I will give 2 more vectors for you and Bob. What else we need? Now we have sorted it. As you can see here, we are starting Alice here and Bob here, which means we have 2 ends of the vector. So we will use 2 pointers. So the first pointer is, let's call it Alice pointer. And the next one is Bob pointer. We don't need a U pointer because Alice minus 1 is U. Because we have sorted the vector, whatever is the highest Alice will take. Alice minus 1 will be the next possible highest. So I will take that. So I mean you will get that. So Alice pointer is starting at files dot size minus 1 and Bob pointer will get 0. Bob pointer is starting at 0. Now I need to return maximum number of coins you can have. So I need to keep track of this. So int sum, this is 0. This is u sum of coins u is getting. Okay, now we can iterate over the vector. We don't need to iterate, we have 2 pointers now. So how do we use 2 pointers? Bob will go from left to right, Alice will come from right to left, and when Bob crosses Alice, we have iterated over the entire loop. So Bob ptr less than Alice ptr. What do? We give the highest possible value to Alice. So Alice dot pushback will get piles of Alice pointer. So Alice got the highest possible value. Now you will get the remaining next highest. So Alice PTR minus 1. This is what you is getting. What is Bob getting? Bob dot pushback. Bob dot pushback piles of Bob PTR. So this is what Bob will get. So these are my players. Now I need to keep track of sum, right? So do sum plus equal to the same thing. Whatever I am pushing to you, I will add it to my main sum. So let's say u is getting the value 8 here. So that will get added to u sum. And we need to, once we have used these pointers, we need to reduce it, right? So Alice will go not one step, but Alice will go 2 steps forward, right? Because I'm using these two at a time. So Alice PTR minus equal to 2. Alice will go 2 points forward. Bob will just go 1 point forward. Plus. Bob is just going 1 point forward. We are giving him the lowest possible value. And that's it. So once we accumulate the sum, we can return it. Okay, so let's run and see. And it is working. So you can see we don't need these vectors actually. We are only interested in the maximum sum, right? Even if we don't push back all these items, we will still achieve the sum. Okay, I use those vectors for our understanding, for our iteration, and see how players are getting their coins. So even without this, we can get our answer. So this is done. So let's submit. And answer is accepted. You see what we have done here? We have started Alice pointer. First, we have sorted the vector in ascending order. We have started the Alice pointer at the right end. We have started the Bob pointer at the left end. And we started giving them coins. But we're not interested in actually giving them coins. What I'm interested in actually collecting the sum. So my sum is getting added based on Alice pointer's location. Alice pointer is at the far end. Whatever is Alice pointer minus 1 will be the next highest value. So I'm just picking those numbers and adding to my sum. And I'm moving the Alice pointer forward and Bob pointer forward. So that's it. So what is the time complexity? So this is sort. So this is n log n, assuming merge sort. And this will be O of n. So n log n is bigger than O of n. So this will be the overall time complexity because there is sorting involved. So that's it. So that way we have formed our greedy criteria and solved another question. It was a good practice for our greedy technique. So if you have any questions, please ask me. If you found this video helpful, do leave a like and don't forget to subscribe to the channel if you haven't done already. Please comment if you have any suggestions or questions. To bookmark the playlist, and I will see you in the next one. Thank you.